Hey, hello everyone and welcome in a new playlist. In this playlist we will discover ETCD. So don't forget to subscribe to the channel to not miss the next video, like and comment this one to support me. What is ETCD? ETCD is just a database, and this database is based on a key value store, really useful for caching and configuration storage. For example, ETCD is really well known for Kubernetes backend, because this is the Kubernetes, the backend that you can use through the API server just to store the Kubernetes, the cluster state and Kubernetes resources as well. ETCD is just a distributed database, so that provides you scalability, fault tolerance and performance due to the cluster mode. What are competitors for ETCD? The first one is Consul for the service registry and the configuration storage, and Consul is provided by HashiCorp company. Zookeeper to store configuration, for example, and Redis for caching is really well known. ETCD is just one of the most used engine, because this is really simple to set a cluster, an ETCD cluster, and to manage it. One of the things that you need to know is that ETCD is based on the Raft protocol. That means that you have a leader election, and the leader is and only the leader can handle writes and reads operations. So this is really important to know that, and that means also that you need to have an odd number of servers. ETCD is developed by CoreOS, or was developed by CoreOS, and now CoreOS is a part of Red Hat company. The main language about ETCD is the Golang language, and now ETCD is a part also of the CNCF, so the Cloud Native Computing Foundation. ETCD is an open source project, so that means that you have a GitHub repository if you want, you can check the code about ETCD. Of course, you have an official website, so etcd.io, and you can check which companies use ETCD, or big company use ETCD, on the adopters page, like this one in Markdown format, but you can have a look on it if you want to check which company use it at a large scale. Of course, ETCD is used in Kubernetes, so that means that you have it, for example, in AWS EKS, OpenStack, Azure, GKE for Google Cloud, etc. When we say ETCD, we have the core component is ETCD, so the ETCD server to make a cluster, but aside of it, you have ETCD-CTL, so this is an ETCD client to manage the cluster, and you have the ETCD util just to make some specific operation on the cluster. Some key features about ETCD. The first one, of course, ETCD, like we said, is really simple, well-defined, and provide directly an API. So that means that if you are a developer, you can use this API directly, and you don't need to develop a specific API to serve some requests or queries for you to get some key, for example, and value of the key. ETCD is a cluster, or you can set a cluster with ETCD. Is better, of course, and with that you can have high availability. You need to have a leader election, of course, and that means that you need to handle the failover mechanism. So to do that, of course, the main failover is automatic. For example, the leader election is automatic, but you need to load balance the traffic through a load balancer or DNS. Another feature really interesting about ETCD is the watches. Because you can, for example, you can through the API, you can query your a specific key and watch all changes on this key in real time. So that means that you are connected always on a specific key and check the changes in real time directly. This is like, for example, a WebSocket. So this is not a WebSocket, but this is, you can compare it to a WebSocket, for example. For the security side, ETCD is really useful. You can set TLS for TLS peer to have TLS connection between each nodes inside your cluster, and also directly the ETCD can provide you an automatic TLS for client connection with a specific certificate. For the performance, ETCD is really fast. You have some benchmarks with more than 10,000 writes per second. So this is really interesting to have it when you need to have some performance. And one of specific things that you have inside the ETCD cluster, when you make some write operations, that you have the wall, so write-ahead logs, exactly like, for example, Postgres. You have the wall also to archive the journals on the disk before to write it on data files. And of course, wall provide you better security. For example, if your server shut down, when you restart the cluster, all journals are replayed just to be sure to have the latest state of your ETCD cluster. Some other key features, you can, and regularly, ETCD make some snapshots to reduce the wall size. Some compaction things, for example, you can store many revisions on each key, and you can set it. For example, you can set that you want to keep only 10 versions of one key, and that allows you to roll back on some keys or to get some older value on some keys. But with the compaction, you can remove all keys to preserve your disk size. Like we said, ETCD is reliable due to the Raft protocol. That means when you make some write or read operation, you have an election just to say what is the latest value that the cluster can provide you, to be sure that all servers have the same value to provide you. ETCD is atomic. That means that you can group some changes and play all together. And if one of the part of the group are not okay, that means that all changes inside the group are not validated. Of course, like all database engine, ETCD provide backup and restore solution. You can make some snapshot to backup and restore a cluster, an entire cluster. So this is really useful to do that. And of course, if you use Kubernetes, you need to do that. You have the CLI, of course, ETCD CTL for ETCD client to manage your cluster, and ETCD util to do that. In backend, ETCD is not the essential, the core about the storage, and inside the ETCD engine, you have what we named Bolt DB. So this is another backend, another database, exactly like SQLite for Python, bbolt or BoltDB. So now it's better to say bbolt. Is developed in Golang language to provide a simple database, and this is what is used by the ETCD. And for example, for reads and write, by default, like we said, this is only the leader that can handle this kind of operation. You can bypass that only for the reads. For write, you are only, and this is mandatory to use only the leader. But on reads, you can use serializable reads, and that allows you to use the leader and also followers, just to give you some answer about all your queries. But in this case, you need to take care about the result, because you can have an inconsistent answer. And yes, Bolt doesn't support concurrent access, and this is why you need to pass through the leader to handle writes and reads operation. And just to have a look on the right path, the right path is just the first step is to write, so the write operation need to be validated by the Raft protocol. The first thing is to write the wall directly on the disk. So this is not a data file, so this is directly some journal. So basically this is like directly your queries. And after that, the data are pushed inside the BoltDB part for the memory storage and the disk storage as data files. So that's it for today. Thank you for following this video. Don't hesitate to subscribe to the channel, and see you in the next one. Bye bye.